Looking at our takeoff editor. So remember, for cut and fill, we have edited it, and we had some cut and fill there, which is okay. Then you are also going to add for material list. You're going to create a new. You're going to call this material list. So come to the material list. Then you're going to start adding materials one by one. The first material, if you look at first wait, you need to look at the section that we are using. What material does it have? Okay. This is the section you created with Martin. This is the assembly we used to create the corridor. Okay, so we're going to look at for the material variables that it had. So we had a surface cost, binder cost, base cost, sub-base cost, capping cost. So we are going to create a material list according to those variables. So for those that have this, you can help me name the materials properly. So I'm going to create, I'm going to create a new material list. I'm going to call this material list. So what is the first material do? What was it called? We can call this asphalt. Okay, so these are going to be associated with the corridor shapes, right? And it's supposed to be a structure, so I'm going to add a corridor shape. In this case, I think this is the corridor shape. I'm not really very sure. We first defined from the sample line group. Okay. This is surface cost, which is asphalt. Then you add it. Then you add a new material shape. Can call this a binder cost. Then you look for the binder. This is supposed to be a structure. Then you add binder. Then we add the next one, the base cost. We're going to look for base. Into the structure, base. Then you add the next one, sub base. It's supposed to be a structure. Then look at sub base. Add. Then the last one is we can call this improve the subgrid. Put this as a structure. Should this be a sub base? Okay, let me first click OK. We need to find out from what we have from our list so that we associate these properly. Parameters. We have base cost, sub base. The last one is a capping layer. And the value doesn't have a value. So I'm no more going to remain, I'm only going to work with sub base. So I can save my list. are there. Don't put me under pressure. I can't calculate. Let me do what I can do. It's not going to take long.
What you want to do engineering hours? Like 20? 30?
Less than 20.
20?
So we are going to come to after you've added our criterion, we are going to come to compute materials, right? So this is the alignment of interest, and this is a sample group that we are going to be computing for. Okay? So there are different criteria we are going to be using. There is cut and fill. So you come here and define for cut and fill what is, e.g., what is the surfaces that you created on the other side. So as you can see, you can't see them here. So there is something that is missing. Let me check for materialist. You can't see them here. They are not imported. So we shall go back to our sample line. You highlight the sample line. Sorry. Highlight the sample line. You come to add source. I think they are all there except the top. Something that I lost. Where's Martin? Martin? Yeah, go ahead. Trying to select, but I can't find them. I can try to select for it, but I can't find them. Select the surface. The source. Add some source. The sample lines. What's this? What's this escape? This one has to stop at 5:30. It's almost done. Once I produce the board, we do the production.
That's why they can't figure out it is easy.
Materialist. Yeah, like that.
We are only here.
Yes.
Why is it not saying there?
Or because when it is a shortcut.
Analyze. Which one is the supplying group? One supplying
I
group.
don't know. Let's choose from that.
Depends on which one is selected. Which one is selected? Oh, it's setting the supplying group.
Made in another actually too. Hello? So once you've done the criterions, you highlight the section view. You come to compute materials. Unfortunately, we had two sample line groups. I'd only chosen the first one, which is not related to the surfaces that we are using. So I selected. Now, if we select this second sample line group, they are telling us we need two criterions. We are going to first add for cut and fill. Then you are supposed to define what Metiana EG is. We are going to relate it to Metiana EG. Then also for the corridor datum, we are going to also relate it to corridor diagram. Then click OK. You should be able to compute for your materials here. Once you're done, okay, it's taking some time.
It's computing.
It's computing. I think it's done computing.
So
Now we can even add volume tables, for example, for total volumes. We can use simple materialist. Okay. Sorry. But one thing I left out, once you're competing for your materials, you're supposed to give them a value for. So you're supposed to name the materialist that you're dealing with. Okay? It is not responding. Okay.
that's
Okay.
called like material.
Sorry?
That's called.
Yeah. So we are going to call this material. Sorry, this materialist. We're going to call it earthworks. Earthworks. Can even add shapes. Remember the shapes for cut and fill. I think they are not here per se, but we can just add colors, shape for fill, or you can, okay, choose a different color, use red, brown, okay. fill. So this is earthworks. Let's click OK. Once you're done computing, you'll be able to show you the coloring for areas where you've filled and where you've cut. Okay. As you can see, where we are cutting to the ground level, they are shading with a different color. Then where you're filling, which is this side, here you're cutting, here you're filling to this area. As you can see, it's dynamic according to what you have. So that's how we deal with cut and fill. If you want to add the table, you can add the table by you highlight. Let me first remove labels. It's clear. Okay, so I can equally add my actually add my volume tables. This is for total volume. Simple. I even have earthwork in my material list. Then I'm supposed to orient it and understand where it's supposed to be. I think I can maybe choose bottom left and click OK. You have volumes for cut and fill area, as you can see. You can edit the table. I can't go really through the styles and labels for the table, but here is supposed to be a change value. Unfortunately for the the UK kids, it orients these variables, the change in terms of 100, which is not a change format. It's just a decimal format. If you remember last time on the beginning, I explained something like this. So you can just change the format to a change format, okay? That orientation. So that is just for the cut and fill. We shall later generate some of those reports. Then when we can still compute for another material, let's choose this. Now let's go to another different material list. We are going to import in a criterion. This criterion is going to be material list. Click OK. And then you are going to be defining our shapes. So corridor 2, surface, let's define it as surface. Binder course, let's define it as binder. Base, let's define it as base. Sub base, let's define it as sub base. And click OK. You're computing the materials. Now here I'm not, I didn't really critically take a notice of the value. So we have a second material list that we have, and this is going to be our material or road material in this case. So we have our values in our shapes. You can even, if you know how to edit the shapes, you can edit the shapes from here, give them different values. Just click OK. So you have your materials. Oh, sorry. So I'll come here, come to your properties, then you can add now materials, add, you can unfill. Now let's add to road materials. We can orient it also that way, and click OK. So we have some values. That means that we have some zero values. That means that here we targeted a different, we didn't target the actual, the shape. The shape that we targeted wasn't actually the actual shape. So you can always correct. Those that we targeted the actual shapes, they're already displaying here, okay? So after you're done with just one group, you can highlight this section view, come to group view properties, then come to volume tables. You can now even add volumes for cut and fill for earthworks, total volume. So let me remove this. Let me add the materials, add the earthworks, then let me change this to road materials. Let it be bottom left, then click OK. Then all the tables will be distributed on all the values in case you want to distribute tables, material tables. Now we have volumes, we have area, we have volume, then we have cumulative volume. If you want to understand, for example, a volume from a volume to a certain chainage, you can just come and look at the cumulative volume in this chainage from maybe the 0 up to this chainage. You can just come and look at the cumulative volume from here, then you quantify from there. So if you have the cubic volume of a certain material, maybe you're starting from chainage 00 to chainage 200, you just come to the table of chainage 200, you look at the cumulative volume, you get out that volume, then you convert in terms of trucks. Good. Of course, for example, base, it's not that they're going to actually use a millimeter of 200. They're not going to use millimeters of 200. Instead, they are going to use something that is higher, so that when they compact, it becomes the actual value. So there is always a compaction factor in this case. So you get this value times the compaction factor, then you get the actual value that's supposed to quantify for. So you get that value that you've gotten. For example, you have 193 cubic volume meters cubed times, if a compaction factor is a 1.5 times the compaction factor, then you get that value. Once you get that value, you convert that value into tons. Then you understand if a single truck, how much tons does it take. If it's around 35 tons, you get that value you have divided by 35 tons. So you understand how many single trucks will need on what? Yeah, on that section. Okay?
Alright.
Yeah.
First prayer will be answered. Maybe they drink something. now. They say 300. I'm like, yeah, this sure does. That's nice. I will. I can put it let's get it and be around perfect. So it's done. Stuff will be as well as we work out. Yes, that's the bus service. Oh, well. I'm thankful for this.
So we have been go through doing output for the cross sections. So to create your cross section sheets, you go to the output button. This button up here. Then you select create section sheets. You click on this. Then you set your alignment name, if at all you have many alignments. Then your sample line group. Then the section view group, which are already set here. Then after you select create sheets. So as you can see down here on the status bar, section sheets have been created, and there are only 3 sheets. There are only 3 whatevers here. This represents the sheets in the model view. So once you open this, Don't fit properly. Let's see. So we shall go with this. We had created a few. Just change the orientation so that they could appear properly on the sheets. The idea there's supposed to be at least a minimum of like 6 on one page. Those are a bit wide. A minimum, yeah. This is a smaller sheet size, I think, yeah. On A3 there's supposed to be at least like 6 on an A3 paper. So this one is a smaller paper size, I think, one we used. So here you can include all the project details. You can edit the title block, then add project details, client's name, all the project details. You can add them here. You can edit your title block at once, and you add all your project details here. So after making all those edits, project details and what, you plot your PDFs. You right click on one of the sheets, preferably the first one. Then you go to page setup manager. Then you add a setup for plotting. So you add the new one. You call it setup 1. Then the printer shall select DWG to PDF. In the plot style, you shall select ZadeCAD CTB. Depends, that's your preference. If you want them in black and white, you can select monochrome. Then my paper size, I set it to A1, 8412. It scales down to an A3 when you're printing. Scale it down. So I will select by window. Then I can snap at these points. Then I fade to page. Then I center my plot. So in the preview, this is how a cross section look like on a PDF after plotting. So after I press OK, then afterwards I can select all my sheets. Then after selecting them, I right click and I say publish layouts. Then I select my page setup one I've just created. And afterwards I select the destination folder of my PDFs. So I set it to the same folder I've been using. I select that one. And after I can either select it to publish from in the background or not. So I say publish in the background. After I say publish, So let's just look at our output. I'll go to our folder in desktop. Now see how the PDF looks like after plotting. So this is how it will look like when you print your PDF. So I didn't adjust this one here, that's why it is looking like this. So now so take you brief through how to create the plan profile drawings. So to create your plan profile drawings, you come to output, then you go to create view frames, then you select your alignment from here, then you go to next, then you say plan profile, then from here select your template for the title block. So just use the default one to 1000. Then view frame placement should be along the alignment. You just press next. Then the profile style, we shall use the standard band size for the silver 3D. After I select create view frames. So it create view frames along the entire alignment from start to end. Then after creating your view frames, you go to create sheets. Then if you want to place them in a new independent drawing, you select all layouts in one new drawing, or you want them in the current drawing, you select add layouts in the current drawing. So let's add them in this drawing. So you go to next. We shall use the default sheet set, default name for the sheet sets. Then you shall go to next. Then you shall align the profile and the plan at the start such that changes along the plan view and along the band, the profile they are aligned in the same position you're trying to check. You do quicks after designing, and after you create sheets. I'll select the origin of the profile view. I will select this point here. So let me repeat. Just created them. Okay. Select the origin of the profile view. So it has brought my my profiles for the prime profile. Then after, I'm going to edit them. I select one of them, and I go to profile view properties. Then I scroll to the bands. I set my profile one to the vertical. The design profile is vertical alignment. Name my profile to the existing ground. Then afterwards, I can add labels to my. Once I've customized my labels for the vertical profile, I can add them from here. So I can use the default ones. Just use the basic label sets. Let me use the detailed design profile labels coordinates. Okay, I select OK. Then the chain edges. I'm going to have sheets with chains of 0 to 500 each sheet, so I'll press OK. So it will make my band here. Then for the next one, I'll do the same thing. Beginning from 500 up to 1000. Be having more or less the same intervals, all of them. So this one will be from 500 to 1000. I add labels for the design profile. I import this label set. I go to the band. I also edit the profiles. I'll press OK. You can try importing the bands you created when doing the profiles from yesterday, and you can see how it looks like. So you can do this for all of them.
You can't do it like at once.
No, you have to do one at a time. Yeah. So let's look at how a sheet looks like after. Let me select the first one here I've edited. So basically this is how it will look like. Then you can edit. You can edit the extents of your viewports such that now here we can see some labels. So to edit the labels, the viewports, you can select both at once, then you drag on one side, and after you can drag it back up to where you can easily see all the information in the band sets. While I'm selecting both of them, I want the starting point to be matching with the 00 here, kilometer 0 at this point. And afterwards I can just move them back until they touch. And I can drag this back also. So you can see my starting point 0 is here, which is matching exactly with the 0 here. Don't mind about the band set, you can always use the band set you have customized. I've always used the default values. So you can do this for all the sheets. So in total there were 9 sheets. So you can do that for all sheets. And after you can use the same procedure for plotting. You can use for the cross-section drawings. Okay, that's it. Have you generated quantities? Have you generated quantities? Quantities? You generated it? Okay. How about exporting central line data and what? Setting out data. Setting. Okay, let me also show you how to generate your setting out data. It's data you share with the surveyors when they are setting out the road. So you come to on the prospect in the tool space bar, you come to the toolbox tab. It's the last one down here. Then you go to, let's use the UK templates. So you shall click on the UK and Ireland reports. Then you go to civil model reports. In the drop down there is an option for alignment. You select the alignments. Then we can choose the alignment increment to chain edge report. This is the one they usually use on site. I right click on it and I press execute. Then I select my alignments which I want to create my data. So I want to select the main alignment for Mitiana. The Mitiana road. Then let's say I'm going to have increments of 10 meters. So then I also set the format for my report. I'll set it to be in Excel. Then after I'll select save. Afterwards I click on create report. So in your report it gives you the coordinates of the alignment at intervals of 10 kilometers and also a tangential direction. Gives you the northings and the eastings and the tangential direction. Okay. I think that's it. I continue.
Good evening, engineers, once again. Yeah. In the interest of time, unfortunately, the events that transpired somehow cannot let us to finish the agenda that we had. Okay? Maybe we would have indicated as a possible 3 weekends, but unfortunately, that's how much we could afford. Yeah, so